the previous video we talked about how to evaluate just a normal function. Today we're going to look at how to evaluate a piecewise function. So a piecewise function, if you haven't seen one before, is kind of just what it sounds like. It's basically two functions or more pieced together to make one function. This function actually comes from some data about immigration in the US during the 1900s. Basically, for a 60-year period, the number of immigrants was decreasing, which is why you see here a negative slope. But then from like 1960 to 1990, it was increasing, which is why right here you see a positive slope. And that's part of why piecewise functions exist, is because trends and data change. So sometimes it's appropriate for us to have one model for a certain part of the domain or a certain period of time, and another model for another part of the domain, another period of time. And this is going to be our main focus for this unit, is piecewise functions. So we'll be talking a lot more about them, what they look like, how to work with them, how to solve problems with them, how to graph them. But for today we just want to know, how do we plug things into them? And the key really is these parts over here on the right. They tell you where this function works. In other words, this function only works if we're plugging in values for t that are between 0 and 60. Whereas this second function only works if we're plugging in values between 60 and 90. So basically you look at the pieces on the right to tell you which equation you plug your number into. So for this first one, p of 30, so you have to come over here and say, okay, is 30 between 0 and 60, meaning this first one here, or is 30 between 60 and 90, meaning this second one here? Well, clearly 30 is between 0 and 60. That tells us we need to use the top equation, the one I've labeled in red. So we would take the 30 and plug it in for t. And then it's just a matter of doing that calculation. Negative 11 over 60 times 30 plus 15 would give you 9.5. Okay, the second one, p of 80. So you just go over here to the right, look at these two areas right here. Is 80 between 0 and 60, or is it between 60 and 90? Well, clearly 80 is between 60 and 90, so that's where I would plug it in. I'd plug it into the green equation. 1/5 times 80 minus 8, which I believe is going to be 8, but let me double check that. 1/5 times 80 minus 8. Yes, it does in fact give us 8. So it's still the same idea where you're taking whatever's in parentheses and plugging it in for x, or in this case t. You just have to know which one to plug it in for. Do you plug it into your top equation or your bottom equation? So let me show you one more example. Say we have f of x equals x squared plus 3 if x is less than 0, and f of x plus 3 if x is greater than or equal to 0. So just so you get a little idea, in case you're unfamiliar with piecewise functions, this graph would look something like this. So on the left side we have a part of a parabola, because that's what x squared plus 3 is. And on the right side we have a line, because that's what 5x plus 3 is. So actually let me color code this, and that might make it a little easier to understand. That goes with that. That goes with that. Okay. So now let's look and see what we have to plug in. So first it says f of negative 5. So you go over to this part on the right and you ask yourself, okay, is negative 5 less than 0 or greater than or equal to 0? Clearly it's less than 0, so we need to use the top equation. So we plug negative 5 in for x. Negative 5 squared is 25, plus 3 is 28. Now we look at this next one, we look at the 0. Okay, is 0 less than 0? Or is it greater than or equal to 0? Well, clearly it's equal to 0. So that's one important thing you need to pay attention to, is where the equal to part is. So that's on the bottom equation in this case, the 5x plus 3. So I plug in 5 times 0 plus 3, which just gives me 3. Now you may notice that in this particular problem, plugging in 0 to either one of those would give you 3. That won't always happen, so you should still be very careful where you plug it in. Always plug it in where it lines up over here on the right hand side. Okay, finally, f of 6. Well, is 6 less than 0 or greater than or equal to 0? Clearly, greater than or equal to 0, so we also plug this one into the bottom equation. 5 times 6 plus 3 will give us 33. So that's how you evaluate a piecewise function. If there's 3 of them, you just look and it's the same process. You would just check and see which interval it falls into, and you would plug it into that equation.